the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is for linear algebra students who are just going through the idea of a matrix equation, AX equals B, kind of like this guy right here. And what we're going to do is specifically in this video, which is an example video, is we're going to go ahead and find if a solution to that matrix equation, AX equals B, can exist if A is this 3x2 matrix, and if B is this vector right here, this column vector, or what we would call a 3x1 matrix. Now let's ignore that note for the time being. I just want to actually build something up here. So at this point, you should have already been told or reviewed the following topic. If the matrix equation AX equals B exists or is true, then that would mean that this equation should be true. And notice all I did here really is just change the matrix A into this version of the same matrix. The matrix I'm just writing with its column vectors. So this is a 2-column matrix, just like the matrix we have right up here. It's a 2-column matrix. And V1, the column vector, will be 1, -3, 2. V2, again, the column vector V2, will be 1, 8, -1. You should also recall that for this matrix multiplication, this matrix vector multiplication to be properly defined, the dimensions, or I should say the size of the matrix A, which is 3x2, 3 rows by 2 columns, should dictate the size of the column vector X. Let's see why that's true here. So I've written the column vector X as the matrix or the column vector X1, X2, or X sub 1, X sub 2. Sometimes I just don't say the subs. And by the way, I should probably rewrite or write in there what vector B is, 0, -11, 3. So let me write that in there. Now, how do I know that the column vector X only has 2 elements? Well, it's because of the fact that when you have a matrix times a vector, the number of columns in the matrix itself should match the number of rows in the vector. And that's just because of matrix multiplication. We've defined matrix multiplication to be basically a linear combination of vectors. So if you were to multiply this matrix right here by this column vector right there, you would imagine swooping this over here. Let's just put a little x1 right above this, and swooping this right here, put a little x2 above that. And you would say, oh, that's x1 times the vector v sub 1 plus x2 times, again, the vector v sub 2. And again, that's going to equal 0, -11, 3. And this is just from, again, the definition of matrix vector multiplication. The product of a matrix and a vector is actually a linear combination of the columns of the matrix. The weights of the linear combination would be the entries of the vector, that is, x sub 1 and x sub 2. All right, so let's go ahead and insert what v sub 1 and v sub 2 are, the column vectors. And this allows us, first of all, to rewrite this as actually a system of equations. But before I do that, now I'm going to go ahead and mention something about that note. Notice we have a linear combination of these 2 column vectors, which are the 2 columns in the matrix A. So we're saying, hey, there must be a linear combination of those 2 column vectors that will turn into the vector B, which means that B is, well, I've just said it repeatedly, a linear combination of those 2 column vectors. But that also means, from our definitions previously, that B must be in the span of those 2 column vectors from the matrix A. Remember, the span of a bunch of vectors, in this case these 2 vectors, is just a space of all linear combinations of those 2 vectors. So since B is a linear combination of those 2 vectors, at least that's what we're saying it's going to be, then B must be in the span of those 2 vectors. It's generated by those 2 vectors. Well, let's go ahead and see if there's an actual solution here, if we can find out what x sub 1 and x sub 2 are. The easiest way right now to do that is to write this as a system of equations. Notice by scalar multiplication of vectors, we get the following. Now that would be me multiplying x sub 1 into that first column vector. But remember, we're actually adding that to a scalar multiple of another vector. So I'll do that all in one fell swoop. And something you need to note here is that the equality of these two vectors implies that this entry must equal this entry. In other words, x sub 1 plus x sub 2 must be 0. And this second entry on the left-hand side, which is negative 3x sub 1 plus 8x sub 2, has to equal the second entry on the right-hand side. And finally, this third entry on the left-hand side should equal the third entry on the right-hand side, and that gives us a system of equations. So all we need to do to find x sub 1 and x sub 2 is to solve that system of equations right there. And I will put that system, or the coefficients of that system, into a coefficient matrix augmented with the right-hand side, and I will use row reduction on that. And at this point, you should be pretty comfortable with row reduction, so I am just going to go ahead and let this roll and get to a final answer. There we go. We have it in reduced row echelon form. This tells us that x sub 1 is equal to 1 and x sub 2 is equal to negative 1. Now let's go back to the original question to see what the heck does this mean and what did we just prove? Well, the question was asking if there is a solution to the matrix AX equals B when A is this matrix right here and B is 0, negative 11, 3. And the answer is, yeah, there is a solution. The solution is the vector X, which is equal to 1, negative 1. That is kind of a long-winded way of investigating that the solution, or investigating if a solution can be found for that matrix. There are faster ways, but for right now, I just wanted to slowly work our way into deeper theory. This example showcases several things that are important. First thing is, a matrix times a vector is actually a linear combination of the column vectors of the matrix, which then can be written, in this case, as a nice, beautiful system of equations, which we can then write as an augmented matrix, which we can then use row reduction and get it into reduced row echelon form and find out that truly there is such an x sub 1 and an x sub 2 that will make A times x equal that B. All right, pretty nice example. I hope this helps you, and I hope you have the best of luck in your linear algebra course. Have a great day.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Yes, listen close, don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.